Hey everyone, welcome. If you've ever found yourself just copying and pasting code from one class to another, well, you're about to discover a much better way. Today, we are demystifying inheritance in Python. We're going to use some really simple visual steps to show you exactly how it works and, more importantly, why it's such a game changer for writing clean, professional code. So let's dive right in.
So here's what we're going to cover. First, we'll start with an analogy that everybody gets: family. Then we'll look at the big problem that inheritance actually solves. After that, we'll jump into the code and see how to write it. We'll unlock the magic of a little function called super. And finally, we'll see how you can make your classes unique and where this stuff shows up in the real world.
All right, before we even think about a single line of code, let's ground this whole idea in something we all understand intuitively. The best way to learn a new programming concept is to connect it to something that has nothing to do with programming at all.
Just picture a simple family tree in your head. You've got parents, and they pass down certain traits to their kids, right? But here's the thing. Kids aren't just exact clones of their parents. They have their own unique characteristics, too. So just hang on to that idea. Shared traits plus unique traits. It's the absolute core of what we're about to explore.
This lays it out perfectly. A parent has these basic features, right? Eyes, a name, the ability to walk. A child gets all of that, automatically. They inherit it. But the child isn't just a copy. They can add their own unique skills and traits on top of that foundation. That's the key concept right there, starting with the base and then adding to it.
And that brings us right to the official definition. In programming, inheritance is simply when one class, which we call the child class, gets to take on all the properties and methods of another class, which we call the parent class. Just like our family example, the child automatically gets all the parent's abilities, and that saves us a ton of work.
Okay, so we get what it is, but why do we really need it? I mean, what problem does it actually solve? The answer is simple, and it's one of the biggest headaches in all of programming: repeating your code over and over again.
Imagine for a second you're building a system for a school. You're going to need a class for a student, one for a teacher, and one for staff. Now look at this table. They all have some things in common, don't they? A name, an age, and a way to introduce themselves. Without inheritance, you're literally writing the same exact code 3 different times. And just imagine having to update that introduce method. Ugh, you'd have to find it in 3 places. That's just asking for bugs.
All right, so we've seen the problem. Code repetition is bad. Now, let's see how inheritance gives us a really clean and elegant solution. Theory time is over. Let's get into some actual Python code. So, first up, we create our parent class. We'll call it person. You can think of this class as our main blueprint. It has the basic stuff. It knows how to store a name, and it has a skill, or a method, called introduce. This is the common, reusable code that all our other classes are going to need.
Now for the really cool part. To make a child class that gets all of the person's abilities, the syntax is so simple it's almost funny. You just write class student person. See this parenthesis? That's where you name the parent. And even with just the word pass inside, which means we haven't added anything new yet, the student class already knows how to do everything a person can.
And here's the proof. We can create a student object, we'll call him Ali, and then we can call the introduce method on him. And look at that, it works perfectly. It prints out my name is Ali. Now think about that. We never, ever wrote an introduce method inside the student class. It just borrowed it directly from its parent, person.
I know, this can feel a little bit like magic. The student class was basically empty, but it could still do stuff. How did it know what to do? Well, that's the power of that inheritance link we created. But what happens when the child needs to handle its own unique data?
Well, that brings us to the next, and honestly, maybe the most important piece of this whole puzzle, the super function. This is the special tool we use to properly connect the child class back to its parent, especially when the child needs to do its own setup. So let's throw a little wrench in the works. A person just has a name, that's it. But a student is a more specific type of person who also needs a roll number. So this means our student class is going to need its own init method to handle this extra info, and that creates a new challenge for us.
This slide shows the huge difference that super makes. Look at the left side. If we just define a new __init in our student class, we completely break the connection. The parent setup code gets totally ignored. But now, look at the right side. By using super, we're basically saying this: hey, parent class, you do your part first and set up the name.
Then, once you're done, I'll take over and handle the student-specific stuff, like the roll number. It makes sure everyone does their job correctly.
So to put it simply, Super is like a special hotline that lets the child call its parent. It's the bridge that makes sure the parent's setup code is reused, not just thrown away. Using Super is what keeps your code clean, reliable, and professional. It's the right way to do it.
You see, a child class isn't just a carbon copy of its parent. The real power here comes from its ability to be unique. It can add brand new abilities, or it can change the abilities it inherited. This is what we call extending and overriding.
Extending a class is super straightforward. We just add a new method, a new skill that is unique to the child. For example, our student class can have a study method. A generic person might not know how to study, but a student certainly does. This is a new power the child has that the parent doesn't.
Now, overriding is when the child wants to change a behavior it got from its parent. The parent person has an introduce method, but maybe the student wants a more specific introduction. So by defining its own introduce method, the child's version gets used instead of the parent's. It overrides the original behavior with its own special one.
So, where does this pattern actually show up in the real world? This isn't just some academic thing. Inheritance is a cornerstone of professional software development. It's used everywhere to build logical and efficient systems.
A classic example is vehicles. You could have a general parent class called vehicle that has basic things like speed and a move method. Then you can have child classes like car and bike. Both of them are vehicles, so they both inherit the ability to move, but they can also add their own unique things, right? A car has 4 wheels, a bike has 2.
And just to make sure our understanding is crystal clear, let's quickly talk about what inheritance is not. It is not just a fancy way of copying and pasting code. And it's not about sharing data between two completely separate objects. It is a fundamental design pattern for structuring your program and reusing code in a logical, is-a kind of relationship.
So, let's do a super quick recap of the most important points. Inheritance is all about reusing code. The parent class gives the basic features. The child class gets those features and can add to them or change them. Super is the key to connecting the child to the parent setup. And finally, a child can provide its own version of a method to customize how it behaves.
We've seen that inheritance is a seriously powerful tool for writing cleaner, more organized code. So the final question is for you. Now that you understand this pattern, where in your own projects are you going to use it to get rid of repetition and build a more logical structure?